Good afternoon. Great to see so many of you here. Welcome to this talk. My name is Hanno, and I am from the Netherlands. And in the Netherlands, I work as an IT consultant at InfoSupport. My Twitter handle is @Hannotify. I thought it was rather clever, get notified about things that Hanno is doing. But if you don't think the same thing, that's not a problem. My wife also doesn't think it's very clever, but I do, so that's good enough for me. I tweet about stuff that I spend way too much time on. So I tweet about programming Java. I'm a musician, so I also tweet about whenever a pop song makes me think of software development. I tweet about version control stuff, stuff that I encounter in the projects that I do. So if you like that, feel free to give me a follow. Now, when it comes to version control, the topic of today's talk, I have come a long way. I mean, when I was in college, back in 2006, I didn't use Git or Subversion. I did version control by email. Who recognizes this? Version control by email? Yeah? Code repository, do a few changes, zip it up, send it via mail to your classmates. This is the final version, and you get a reply 10 minutes later. No, this is the final version. No, this is the final version. You get it. When I started my first job in IT, 2007, I was really eager to learn something new in the world of version control, but at that place of work, they used version control by USB stick. Also very modern. You know, you would just put your chain set on a USB stick, walk over to a central computer, merge it manually over there, and go to your workstation back again with a fresh copy. Disaster. Thank goodness it's 15 years later today, and I have managed to gain some experience with proper version control systems like Subversion and Git. I even teach a Git course at InfoSupport, a one-day course where I teach our junior colleagues about how to use Git as a developer, so lots of command line stuff. And also the pros and cons of distributed version control, how it compares to earlier version systems like CVS and Subversion. And this is actually one of the course slides, and it displays which version control systems have emerged until now and their publication date. And it tries to put this into perspective by comparing the publication date to the most modern phone available at the time. So for example, the Nokia 3310, I had one of those. Who had one of those? Nokia friends, hi. Correlates to Subversion. Both this phone and Subversion are indestructible. And the battery was excellent, but Subversion doesn't have a battery, so that doesn't make any sense at all. Whereas CVS, published in 1990, obviously ancient, refers to, oh, this one here. It even has a power plug, also ancient. And at the end of one particular course day, a student came up to me and she said, I really like that you taught us Git and I'm going to be so happy using it, but it seems like kind of an old system, right? I mean, it was published in 2005 and back then it was 2019. Why are we still using it 14 years later? I mean, isn't that kind of old for a version control system? What's going to be the next big thing? And to be honest, I couldn't answer her question. I wasn't sure. I had no idea. I thought, well, Git is probably going to be around forever. But of course, I didn't say that out loud, because nothing lasts forever in IT world, right? Next week, there will be a new JavaScript framework probably, so you never know. So I couldn't tell her that. And I really didn't like it, so I decided to investigate it for a bit. And things got kind of out of hand, because I didn't just tell her the answer, I had to investigate it, and the investigation turned into a conference talk. And it's the one you're attending right now. So welcome to you all, thank you for attending, and let's try to find the answer to this student's question together, shall we? And I think to answer the question, we have to discover what factors are influencing the popularity of version control today. So let's take Git as an example. Why do we think Git became so popular? Well, if we look at this graph for a moment, we see one of the reasons. So this is a graph of the popularity of version control systems until 2016, and we see that from the moment that GitHub was launched, right here, Git started growing more rapidly. Also, when Bitbucket, a hosting service that supported Mercurial initially, but started supporting Git around 2012, Git started to rise even more in popularity. So a very important factor is hosting platform support. But I think there are more reasons. For example, killer features. So when Git was published, it was meant as a replacement for Bitkeeper, the only distributed version control system at the time, but it had a commercial license. And so when this commercial license was also going to be active for open source development, a lot of new projects emerged, Mercurial and also Git. So free to use. And it was meant to be fast. So everyday operations should always take less than a second, is what Linus Torvalds said about this. And it would support easy branching. Unlike CVS, for example, in a branch at CVS is just a carbon copy of a directory. It could take a very long time with a lot of nesting and small files. Hosting platform support for Git is, of course, superb. I mean, there are 18 different websites that offer public Git repositories as of 2022. And open source community support is also an important reason, I think. Git has been the driving force behind global open source development, with contributors spread across the globe. And I really like to use these strengths of Git as prediction variables, factors that will influence our prediction for the next big thing. And I would like to add another one. I call it the handicap of the head start, because it's always the hardest for the top product to remain the top product. Only if you innovate regularly, you will remain the top product. And not every product has managed this. For example, Internet Explorer has just been declared kind of dead, right? In the start of this year. Failed to innovate, failed to add tabbed browsing, for example, during the browser wars, and it got overtaken by Firefox and later Google Chrome. This is the same thing that happens to Subversion, or maybe to your favorite football team. I'm a Feyenoord supporter for the Dutchies in the room, so I really know what it is to get on top and not stay there. I mean, we only get champions like once in the 18 years, so I really know how this feels. When we put the graph data into a table, this is what we see. We see that in 2021, Subversion is down to 8%, and Git is up to 74%. Now, the graph didn't last until 2021, so I had to extrapolate here for a bit, but I think these numbers are quite correct. The question is, what will happen in 2032? Will Git still be the top one? Well, of course, we also have to keep into account that new products will emerge. So let's add some new products to the mix. In the rest of the talk, I'll add two newer version control systems to this table, and they are called Fossil and Pijul. So let's talk about Fossil first. So Fossil has the following features. It is a distributed version control system. It was published a few years after Git, and it has integrated project management, so bug tracking. It has a wiki, it has tech notes. Sometimes it's called GitHub in a box. So all this stuff, all these features, you can pull up on your local development machine through the command Fossil UI. I will show you in a bit. There's really not need to use any third-party products here, because you have a fully featured developer website available when you use the version control system Fossil. So like I said, there's this built-in web interface, and there's also an auto-sync merge mode, which means, like in Git terms, after you commit, you automatically push if there are no conflicts. But you can also use a manual merge mode if you want. And Fossil can also show descendants of a check-in, whereas in Git you can only show ancestors. With Fossil you can also use descendants, so relationships between commits actually are bidirectional. And it supports operations on multiple repositories. So if you're doing microservices and every application is a separate repository, with Fossil you can perform operations on all repositories that it knows of. And it has a preserve all history philosophy, which means there is no rebase in Fossil. So you can't change the history. Would also be a very bad name, Fossil, right? For a version control system that could change the history. So the name is well chosen, I think. It was written specifically to support the development of SQLite. And the SQLite project also uses Fossil for their development. And these projects, they reap the benefits of one another, because Fossil just uses an SQLite database to store the relationship between the check-ins. There's free code hosting at chiselapp.com, so you can use that if you want to try out Fossil. But actually, Fossil just needs an SQLite database. So I guess any hosting space provider could provide this and do the job if you want. So kind of flexible. Like I said, you could just host it yourself. Now, a repository in Fossil is, like I said, a single SQLite database file, and it contains relations between the check-ins, so it can produce both ancestors and descendants. So let's see how Fossil works in a quick demo, and I'll switch to a different screen for you. There we go. So we're in an empty directory right now. Let's enlarge it for a bit. And we're going to create a new fossil repository right here. Let's create a demo directory, and let's create a new repository. Now in fossil, the repository file is kept outside of the directory. So this is different than in Git, because in Git there's the .git folder, the nested folder. With fossil, you keep the repository file outside of the directory. Let's change there into demo, and then we have to connect this directory to the repo file that's in the folder above us. And now we have connected them. So let's create a Java file. We have created it right now, and let's just add this file to our repository. We've added it now. We can see the changes if we want. There it is. And we can commit like this. Just looks like Git actually. Commit -m, initial commit. There we go. We've got a new commit. And if we want to see this developer website, we just perform the command fossil UI, and there it is, our fossil UI. It shows us these check-ins and the history of our repository. You can browse the files if you want. Okay, so I've called this file random.java. So the idea is to provide some random implementation here, right? So let's create a class, random, and let's have a main method here that just sends to the system out the result of the random call, right? Private int random, and well, every time I want to generate a random number, I always try to roll a die, like in the XKCD comic. Someone recognizes it. Roll a die to get a random number, so I'm just rolling it to people over there. Maybe you can help me out to see which number it lands on.
1.
The result is 1, ladies and gentlemen. So let's return 1. Generated by a die guaranteed to be random, right? Yes, thanks. I'll recover that later. Okay, so let's return to our fossil repository. Close the UI down, just for the sake of sanity. Oh, I've forgotten something here. Oh, sorry, yes, the demo effect. Thank you, folks, very much. There we go, 1. I can run it again, but it wouldn't be very interesting, right? So let's add this new random implementation to fossil. And do a fossil commit again. Implement random. There we go. We have committed it, right? But the fossil UI isn't running because I killed it. There we go. There's an implement random. Now, if you would create a branch in fossil, you would could also, based on the check-in, see its descendants. So this is a short talk. I'm not going to be able to show very much of that, but that's a nice feature of fossil, I think, in my opinion. So returning to the slide deck. So Git versus fossil. Actually, fossil is really meant for small-scale teams. So the fossil team and the SQLite team, they are both small teams, 4 or 5 developers, and they all know each other personally. Whereas with Git, this is a major global open source project, 5,000 contributors to the Linux kernel. So the purpose of these two version control systems are very different. Also, the engagement is very global with Git and personal with SQLite and with fossil. And the workflow is also very, very different. So with Git, the workflow the dictator and lieutenant workflow was thought of by Linus Torvalds and his co-workers. In this case, because the Linux kernel is so vast, so many lines of code, Linus only trusts a few specific people for certain parts of the Linux kernel. So that's why he calls them his lieutenants. Whereas with fossil, this is a very small team, so the workflow is built on trust. So surely something to think about is why are most projects using Git, a version control system that was designed to support a globally developed open source major project like the Linux kernel, because are all projects actually like that? Or are a lot of projects actually like SQLite and fossil, a small scale team with a limited amount of team members? Not saying you should switch to fossil, I'm just saying maybe try it out for a change and see if you like it. Okay, so the second version control system is Pickle. Time to dive into that. And the first thing we need to address is the name. So it's a Spanish word for a bird that's native to Mexico, and it's a bird that is known to do collaborative nest building. So I thought they kind of like the analogy of collaboratively building something using a version control system. And they tried different names, but this one is very uniquely Googleable. And, well, they have a fair point. So Pickle it is. This version control system was first published in 2015, and it's a version control system that is patch-based. Also distributed, by the way, but the patch-based thing is kind of neat. It's based on the sound theory of patches. They've got all these mathematical proofs that their patch theory works, and that it doesn't lead to many conflicts, with all kinds of examples. I'm not a mathematician, but if you like that stuff, you should really check out their website. It's not by no means the first patch-based version control system, because Darks is also a version control system based on patches. But Darks never got really quite popular because it was kind of slow. And one of the main features of Pickle is to fix the slowness of Darks. Yeah, like I said. It also has a feature called interactive recording, which means when you have added files to your, in Pickle, this is called a patch. So added files to your patch, you can still choose which parts of the file you want to include in your change and which parts you want to leave out. Some quick facts about Pickle. It is written in Rust, which is one of the faster languages around if you see language speed comparisons. And it's been bootstrapped since 2017, which means the people at Pickle use Pickle as a version control system for their source code, just like the people at IntelliJ use their own IDEs to develop their own IDEs. So they eat their own dog food, basically. And you can use free code hosting at nest.pickle.com. Their hosting platform is called the Pickle Nest, like the birds that do the collaborative nest building, so it all makes sense now. And like I said, Pickle is based on a patch-oriented design. So a patch is an intuitive atomic unit of work, and it focuses on changes instead of differences between snapshots. So this is what happens with Git. You create a version of a file, you create a next version, and Git saves the two states of the file. But using changes with Pickle, Pickle stores the things that you added or removed from the file, not the files itself. Also means that applying or unapplying a patch doesn't change its identity. With Git, it does change its identity. When you want to apply a commit to a different branch, it gets a different ID, and it's not exactly the same commit. Internally, the contents of the commit will be similar, but it won't be identical. And the end result of applying several patches in Pickle is always the same, regardless of the order in which they were applied. And Pickle does this by keeping track of dependent patches. So if I create a file in patch 1, modify it in patch 2, when I want to apply patch 2 to a different file set, Pickle knows I have to apply patch 1 first, and then after that I'm going to apply patch 2. This also means that rebase and merge don't really exist. Applying a patch is just like applying a patch. And a merge, if you really would want to do a merge between two, in Pickle, a branch is called a channel, so a merge between two channels, well, you just have to apply the patches that are the differences between those two channels. But there's not a merge command, and there's certainly no rebase command. Pickle does model conflicts, so conflicts can happen, but to resolve a conflict, you just have to add a third patch on top of the two patches that are conflicting. And because these patches, the identities never change, you can always use the third patch that fixes the conflict in another spot or at another channel to fix the same conflict. So you don't have to fix conflicts over and over again like you sometimes have with Git. Let's make it more visual. I think I'll use the second slide actually. Like if commits were bank transactions, this is what would be the difference between snapshot and patch-based. So if this is my bank account and my initial balance is 100, Git would store 100, but Pickle would store, apparently you've gained 100 right now. Euros or dollars, doesn't matter. When I get paid by my employer, it's an okay salary. It's not much, but 300 euros apparently. Git would store 400 because this is the end result of the change. But Pickle would store plus 300, because this is the actual change. And then I have to pay my heating bill. And of course, well, all balance will be gone, because that's very expensive nowadays. So Git would store 0, and Pijul would store minus 400. So this is essentially the difference between Snapshot and patch-based systems. Okay, so let's demo this for a bit. See how it will work. So here I've got an empty directory with Pijul installed. And the first thing we need to do is initialize the repository, right? So let's run a Pijul init demo. We get a new folder just like with Git. So that seems easy enough. Now I want to keep track of the movies I've seen. This is my use case. And this week I'm watching one movie. Next week I'll watch another one. So I'll create a channel for next week. And if I'll ask Pickle, what channels do you know? Sorry, it's called channel singular. There's a main channel and a next week channel. So right now we're on the main channel, right? So let's create a movies file. Well, this week I'm a DevOps, and in my spare time I can watch the movies I like, right? Because I'm all alone right now. And I was planning to watch a movie by Quentin Tarantino. I saw this one was on Netflix. It's been a long time coming. I should have seen it already. I didn't. So let's make sure it happens this week, right? Let's tell Pijul that this file exists, and let's record it like so. Like record -m, watched a movie. Movie. Here we go. Now we get an edit screen. It says the message. This is the author. This is my author key. It's very inclusive. I can change my name later to Hanno instead of Hanno, and it will still know that this was me. So I really like the feature. And here I can say this line. I need to add this line, or I can skip it. And if there will be multiple lines, this is the interactive record, so I can comment things out here if I want. But I'm not going to do it right now. I'm just going to save it like this. I think I'm going to watch another movie. So let's edit it out again. Movies. But this time it will be the next week, and I won't be here. I will be home with my kids. And my kids want to watch The Little Mermaid. So let's add that movie to our list also. Watch another movie. There we go. Syntax errors. I'm not sure what I did. Oh, this is what I did. Sorry. Now, if we ask for the Pickle log, we see all the patches that were here, right? And what I want to do is take this patch, so I'll copy it right now to my clipboard, and change channels to the next week one. Pickle switch channel next week. Channel switch, it's channel switch. Should have known that. Here we go. And of course, those patches are not present in this channel, but I can apply it right now. And what has happened, it has applied 2 patches, because it can't apply an addition in a file that wasn't there in the first place, so it knows there's a dependent patch. And I need to apply that one first. And I'm not going to be able to show you, but it's just as easy with unrecording. So I can unrecord a patch, and Pijul will know what patches are dependent of the unrecording. So that's really nice. These are all the commands, actually. The command I also like is credit. I really hate the git blame. That's so negative. Pijul just says credit, because developers are creating good stuff. So that's a nice touch by the Pijul team. Yeah, I like that. Let's return to the slides to wrap the talk up. Okay, so what about Pijul's current status? Here we go. Can we use this in production? Well, it has been a research project for quite some time, but it has entered version 1.0 at the beginning of this year, and they're currently in a beta phase, so I'm going to really keep track of that and see if I can introduce it at one of my projects. Right now, I've only used it, I think, for keeping track of slide decks, working on it with people collaboratively, and I really liked it until now. And I think it's quite promising because it is quite simple to work with patches, and you don't get this very familiar feeling that, oh, I've done something wrong with Git, and now my repository has gone to hell, and I don't know how to fix it. These things happen quite not so often with Pijul, a lot less often, actually. But of course, there are a few drawbacks, and I'll try to plug them into our prediction variables. So these were the prediction variables that we created, right? Just before we did the demos of Fossil and Pijul. Killer features, hosting platform support, open source community support, and the handicap of a head start. So now that we have seen a bit of Fossil and Pijul, let's score them according to these variables. Well, when we talk about features, I gave Pickle the highest score because I like their fast patch-based versioning. Especially if you're working in teams with both technical and non-technical contributors, it could be very, very good for them to cooperate with a version control system that doesn't require so much details about the version control system in the first place. Like with Git, you have to, well, basic usage, it's fine, but when you do something wrong or something you didn't intend, you need a very bizarre magic command that you can't remember and have to Google every time you need it. So with Pickle, this could be a lot easier for them. And I think I like the show descendants feature of Fossil, and also the fact that it focuses itself on small teams. I think there are more small teams in the world than large teams, but I've scored them just a bit lower. So when it comes to hosting capabilities, of course, Git will win this one, because like I said, there are 18 different places on the internet where you can host public Git repositories. And the Mercurial repositories are all right. I guess there are like 7 or 8. Team Foundation has only 1, Azure DevOps, and Fossil and Pijul both have 1. So they have the potential to grow, but still it's not their strong suit, right? And we have to wait and see how popular they get. I think Git and Mercurial have both proven that they are superb in supporting the open source community. And we have to wait and see how this goes with Fossil and Pijul, although I can tell you already now that because Fossil can also be hosted by yourself at your own service, that will not help them in the open source community, whereas Pijul has the Pijul nest and you can share your projects there, so a bit more potential there. The dominant projects suffer the most from the handicap of the head start, so Git and Mercurial suffer the most from that. And when we add it all together, I think that Git and Mercurial will, well, they come out okay. Team Foundation, I don't think we'll be using much of that anymore, especially now that Azure DevOps supports Git repositories. Fossil will stay about the same, and Pijul, I think, will gain some. So when we have to put this into percentages, of course, this is a lot of guesswork, right? But it's the best I could do with the data that I have right now. I think we'll see something like this. So Git has a very high top already, and compared to 2021, I think it will grow a bit further. But Subversion won't grow; it will only decline, and Mercurial will also decline a bit. And Team Foundation, I think. In my Git course, I get a lot of people who were used to Team Foundation and want to learn Git right now, so I think that will also decline for a bit. And I think Fossil and Pijul will grow for a bit. I think they are good projects. I think they'll gain some traction in their own communities. But of course, we have to wait and see whether they will gain global traction. So I've put them at 6% and 3%. Of course, they are all guesses. But like I said, it's very much dependent on whether more hosting platforms want to support these version control systems. I've just sorted it by popularity for your convenience right here. If you're really into the topic, I've compiled a list of articles that I read in preparation of this talk. I'll also tweet the slides so you can read them later if you want. Basic question at the end of the talk, I think, is now what? What should I do with this information? Well, one of the things that I learned by doing research, or actually 2 of the things I learned, is a lot of projects are nothing like the Linux kernel. I think most of the projects I worked on during my working hours were nothing like the Linux kernel. So why don't you try fast over change and see if you like it? And secondly, Git snapshotting and the situations that you can find yourself in after doing an operation that you didn't intend might be too technical for the average user. So why don't you try Pijul for a change? Maybe for a side project, work on it with a few people, see if you like it. And you can, like I said, you can use it because it is production ready and stable. It's a short talk, so not really much time for public questions, but if you have some, you can come see me after the talk. I would like to thank you for your attention and have a great conference day.